Today I'm going to give a quick lesson on standard deviation, specifically what standard deviation is, how to calculate standard deviation, and how it can be used. To get an understanding of standard deviation, I'm going to use my family as a real-life example, and we're going to talk specifically about heights. My mom is about 5'7", so that's about 67 inches tall. My dad, he's actually quite tall. He is 77 inches tall, meaning that he is about 6'5". And I'm pretty tall myself. I'm about 75 inches, or 6'3". So if you actually take the mean height of our entire family, that breaks out to about 73 inches, or 6'1". Now, I'm at the age when people have approached me and commented that I'm going to have quite the tall family when I settle down. So it's made me quite curious that I've asked myself, is it reasonable to expect that my family will be tall? So can I expect my kids, or a child, can I expect that child to be like the average? What are the chances of that happening? Or maybe can I expect my child to be 6'3"? Is that typical? And another thing that I've been curious about is, can I expect my child to be much shorter, like 5'5"? Well, so let's explore these answers, and let's explore the likelihood using past measures that we've used before in statistics. So let's look specifically at the measures of center, and let's try to answer that question, starting with the mode. Well, let's see what our mode is out of our family's heights. So out of the three heights, I can see that there's no repeated heights, so therefore there's not really a mode. Well, that's not really very helpful in understanding what the likelihood is that my child will be a specific height. So I don't think I can use mode. But what about mean? Or median? And these two are quite helpful in that it does give me an actual middle value. However, I would like to also understand what the, is it reasonable to expect that a child could be of a specific height? If my child is going to be 6'3", is that normal? Or what about 5'5" or below? So it looks like not only would I need to get a middle value, but I want some kind of number or value that would give me an indication of spread or a range. And that's where standard deviation comes in. Because standard deviation is a metric that describes the spread of a distribution of data. To get the standard deviation, and I'm going to use the variable s to stand for standard deviation, you must take the square root of the squared differences between each of the values in the data set, x, and the mean, and divide that by the number of values in the sample. So let me tell you how I can apply that in terms of each of my family members' heights. So I'm going to bring down each of the heights of my family members. That includes my mom, she's 67 inches tall, my dad, who is 77 inches tall, and then myself, who is 75 inches tall. And I'm going to subtract each of the heights from the mean. Now I said the mean was about 73 inches, over here highlighted in red. So I will be subtracting each of these values by 73. Now let's stop for a second and tell you about a situation on why we have to square these differences. If I were to just stop right here, notice that I would have a difference of -6 here, 4, and 2. So if I were to add these values, notice that I would get 0, which is more like a net difference rather than a total difference. So I'm after the total so that my standard deviation is accurate to my data distribution. So I'm just going to erase these values that I've created because ultimately I need to square these differences. So I have to square each of these differences and then add these together. So all of these added together would give me a grand total of 56. And remember, now I have to take this, all the square differences, the sum of that, and divide that by the number of heights in my sample, which is 3. When I do that, I get a total of 18.67. Now 18.67, this is actually a very important number in itself. This is called the variance. And I'll explain the significance of variance in later lessons, but just know that I'm not done. Remember that I actually have to take the square root of 18.67. I have to reverse the process. So when I do that, I get a standard deviation of 4.32. And so this is my standard deviation. So what can we do with our standard deviation? And notice how I've erased a lot of our work to calculate the standard deviation, but I've kept the number right here below the pictures of my family. So as a reminder, standard deviation is a measure of how spread out the heights of my family are. So let's see the heights that are within one standard deviation of the mean. So I'm just going to write our mean a couple times, and then I'm going to both add the standard deviation to the mean. Sorry, that's a little bit sloppy. And subtract the standard deviation from the mean. The sum of the mean and the standard deviation is 77.32 inches, and that's roughly 6 feet 5 inches if we convert it. The difference is 68.68 inches, and if we convert that, that's going to come out to about 5 feet 9 inches. Let's come back to our original question about my future child. Is it reasonable to expect that my child would be about 6 feet 1 inches tall? Well, that falls within the range of 5'9", and 6'5". So therefore I can conclude that that is pretty reasonable because it falls within one standard deviation. Well, what about a child who is about 5 feet 5 inches? Now as you can see, that's shorter than 5'9". So therefore it may not be as reasonable because it can be looked at as too short. Now this probably raises a couple questions, like just how unusual is it for someone to be 5 feet 5 inches? Or now that I know 6 feet 1 inches is expected, how much more or less expected is 6 feet 2 inches? And plus we can be much more specific about the likelihood. But we're going to answer all of these questions in future lessons.